Hey guys, hope you're doing well. This is Sid, and I'm back with another Golang tutorial today. Today we're going to be looking at something that I'm quite excited about. It's a framework called Testcontainers. It's a framework for um, spinning up Docker containers to virtualize things for your tests to be run, and you can do that programmatically with this framework. And so if you watched any of my channel videos, you know that I'm quite big into testing, and I like to find new testing tools for Golang and other languages. And this is a great framework that I use all the time, but I wanted to share with you. So if we look at Testcontainers website, bring that up here, testcontainers.com, you can see it says Testcontainers is an open source framework for providing throwaway library instances of databases, message brokers, and so on. And really, it interacts with things like Docker, if you're familiar with Docker, which is a virtualization tool on machines, or Podman, or any kind of other virtualization framework that people use. And it allows you to programmatically spin up things in your tests to be run inside Docker containers and then interact with them using a really nice API that we'll look at today. You can see it had a bunch of different bindings with different languages. So Go is highlighted here. That's the one we're going to be using today. But there's other things like Haskell, which happens to be one of my all-time favorite languages to use. I might do some Haskell videos on this channel when the time is right. It's one of my, like I said, all-time favorite languages to use. But today we're going to be looking at the Go bindings. But it also, aside from bindings, has a bunch of different modules for services that it supports out of the box. So really popular things like Postgres, local stack, MySQL, Kubernetes, whatever you really need. There's usually a test containers module that you can use to make it really easy to spin up these services on demand and in your Golang project. So let's have a look at what this actually looks like in Go. So let's bring up Neovim. And what I've prepared here is we're going to be writing a really simple database client for a MySQL database, and we're just going to test it out by spinning up some test containers to run it against. So I prepared a little bootstrap here to get us started. If you've watched any of my other videos, you'll be familiar with this kind of code style. It really isn't anything particularly fancy. But what it is we have a DB client struct, and we have some profiles. This is what we're going to be fetching out of the database. And so the database will just hold a table of some profiles, and they'll have a name and an ID. And if we start by implementing the constructor function for a new client, we'll do that together. Again, this is not really a tutorial on MySQL connections in Go. We're just kind of building something together so that we can try it out in a nice test in a second. So we'll start by declaring a SQL.open. This is our you create a SQL database client in Go. And we'll just assert that there's no error there. And then another thing we can do is we can set some base parameters on it. So we can say it will time out after 5 minutes. This is something that we might want to test, right? And you want to buy tests. We can set the maximum open connections. Another thing you might want to test just to get us started. And then in these kind of Go SQL driver scenarios, you don't really know if you've successfully connected until you actually try pinging the database. That's one thing we'll do as well, is we'll ping the database, and if we fail to ping, we'll say something clearly didn't really work out. On the other hand, if it doesn't fail, then we'll say, great, we successfully pinged the database. And if that's the case, then we'll return our new struct that we created, and we'll say connection string is the one that was asked in, that'll be used, and the DB object is will be created there. And then finally, we'll say no error was returned. Great. So here we have a really simple client constructor for the MySQL database. And with this DB object, we can actually do a lot of things. We can call a query, we can call execute SQL statements. So that's what we're going to be doing in the test in just a second. But this will basically allow us to instantiate this client and try that. And so let's get into what we're really interested here, which is our actual test, right? So we've got some test integration, client integration tests. And again, I prepared a little framework here to get us started. And all it is, if you've watched my testing Golang video, is you can go and make a test suite where we're going to do some behavioral driven testing. So the behavior that we want to test is we want to be able to fetch from the database. And to do that, we should successfully connect to the database, and we should successfully fetch a profile from the database. So let's try that out. So what does this look like? So I mentioned the test containers have different modules and different bindings. So there is a test containers Go package and a test containers Go modules MySQL package. So I've pulled those two things in. What we can now do is we can write our tests in such a way that we can instantiate a test container containing a whole database, so we don't have to build anything or spin up anything on our own machine that's not containerized inside these Docker containers. So basically what it allows us to do is it allows us to run our tests in isolation, run them in a programmatic way, configured way. That means that they are set up exactly how we want them for the test to be conducted, with almost no environmental impact or any kind of other thing that could be getting in the way of us testing our code correctly. And that's what I think it's such a powerful concept to use. This library it really easily, as you will see in a second, allows us to programmatically spin up these things on demand. So let's get started. So we're going to start by declaring a container. I'm going to say a test container is a container. And then the other thing we need a context. So this is a common thing in Go, is that when you're running any kind of multi-threaded thing, you normally need a context. And then we'll say we need a connection string as well, because that's what our client needs to actually connect, which you remember, I think, in the new client call. So let's start by creating a context, and we'll just use the background context. If I could spell properly. Background. And then that's created our actual test container. And the way we do that is we call the MySQL module and we say run container through this function, create an instance of the MySQL container type. Great. So what that takes is a context. All right. Already started. And then it takes a bunch of options. So let's look at what kind of options we can put in there. Now, the first one is, let's give it a Docker image. So we'll say test containers.with image. So this actually passes it the name and the tag of a Docker image to use. And this is really powerful because it means if you have a specific version of MySQL or anything that's inside a Docker container, which is in most development tools, you can just give it the image and it will pull it down from the Docker Hub or wherever you tell it to pull it down from and instantiate it for you. And then once you have that, you can pass it some additional options. So let's look at the MySQL module here and say with database. So this is basically giving the name to a database. Let's call it foo, for example. And then we can say with username as well. Let's give it a default username. So if you wanted to set up a database with some credentials, this is how you could do it. You could do it dynamically. If you have some credentials you want to try out, it doesn't really matter, but you can really easily here, using this API, declare that it's going to pull down MySQL, it's going to run a Docker container to set it all up for you, and then it's going to instantiate it with these credentials. And to make it even easier for us, if we just make sure that no error occurred, so we still have test rights, we're going to say, let's make sure there is no error. To make it even easier for us, it has a bunch of utility functions too. So we're interested in the connection string, all right? So now we spun up this container. So give me the connection string is what we're saying. So we can actually call container, but connection string, and pass it the context. There we go. And what this should return is not just the connection string, but the pre-populated connection string for us to use, because it knows that it's a MySQL database. And it will also give us the correct port, but the database is listening on, because we're spinning up a Docker container. It's going to get a dynamic port, and we're actually going to be able to retrieve the full connection string with the port that it was spun up of using this easy function. And then we're just storing a reference to our container. And the reason why we're storing a reference is that once we've actually created this, once we run our suite of tests, we want to go in and we want to make sure that we terminate it to clear up our resources. So we'll call container that terminates to pass it the context again. And then we'll just make sure that no error occurred, right? So there we have it. These are really the only two things we need. So now when we run this test suite, what we expect to happen is that before the whole suite is run, it will spin up a MySQL test container inside a Docker container. It will give us a connection string to connect to this container. It will create a database of name through with a root user and a password. And it will terminate the whole thing and pull it back down for us automatically when our tests are run. So let's implement the first little test here, which is it should connect successfully to a database. Let's start, just for our own sake, by printing off a connection string. Make sure that that's working. And then we can instantiate our client. This is what we actually wanted to test, right? We have this internal library that we're trying to test. So we'll call new DB client, go on that we create together, and we'll assert that no error occurred, which means that it actually would have pinged it on the hood. As you remember, we implemented that it should ping when it actually creates the client. And then we also just assert that the actual client we created is nil. So with this, we actually have a valid test suite that we can run. So let's try running it and see what that looks like. So we can go in here and just run go test. And here you see a bunch of output, and we'll go through that in a second. But let's just see what it comes up with. You can see this is Testcontainers at work. It's telling you that it's building containers, and it's telling you that it ran 2 tests and they both passed. So let's have a look at the output. So we ran go test like we normally do. And it comes in here and says, I'm running test containers. I connected to Docker. So I'm running Docker on my machine. You can use Docker or Podman, any kind of virtualization that you want. And it says, great, I'm spinning up a test container, and I'm spinning up a MySQL 8.0.33, which is the image that we gave its container. It created the container, waits for it to start, waits for it to listen on a port, and then when the container is ready, it sends this container is ready event, which basically tells this, now you can run your test because the container is ready. So this is our test kicking in. So here we are printing up a connection string that he gave to us for free, and then we passed it to our client, and it successfully pinged the database, right? This is already a great test. So not only have we successfully connected to a MySQL database without knowing anything really about MySQL or installing it or configuring it, we just used the Docker image, pulled it in, used some basic API functions and a connection string, and we're ready to start exercising our client against this database. Let's do one more thing. Let's implement this other test here, which is we should be able to successfully fetch profiles from a database. Now you might think, but we don't even have anything in the database. The database is empty. We've told it to spin up the MySQL database. We've created the database. There's nothing in it. Normally, when you're testing databases, you want to basically instantiate it with an initial schema or some initial data, right? And there's a really easy way to do this. In Testcontainers, which is the MySQL database module, provides a way of loading one or more SQL scripts when you instantiate a library. So I've created a scripts folder here, and I have an init.sql. And if you look at what this is it's a really simple little script that creates a table profile. The profile table has 2 fields, an ID that's auto-generated, and a name, right, for the profile. And then we actually insert one value into the profiles, which is profile 1, right? So we can actually tell Testcontainers to run this script when we start over and instantiate our database. And the way we do that is we add another option, which is the with scripts function. This takes a path to one or more scripts for it to run at the start of our test container. So now it will create the database, set it up for us, and it will also instantiate it with a schema that we can query it. So let's try it and go down here and query it. So we've created a client here again. So let's just call a function on it. And the way we do that is we've exposed the DB object on our client. So we can call the query function, and we can pass it a SQL statement to run. So remember how we have that table profile? We are actually going to select all from profile. And then the result coming back is an IO closer. So we should go ahead and close it eventually, and we'll make sure there's no error. And then again, this is not really a SQL tutorial, but the way you go through results from a query like this is you call the resNext function to go through them, and then you can bind any data that you got back to variables. So let's create 2 variables, ID and name. This is what conforms to what was in the profile, if you remember. And then we'll use the rest.scan function to bind this data to these variables. So, and the final thing we can do is let's just print it out just to see that it seems to work. So we'll print out ID and name. Very good. So here's our next test, which will basically go in and try to select from profiles what we said we wanted to do, right? Fetch a profile. Let's actually fetch more profiles from the database. So let's try running it. So we'll run our test again and see what happens. You can see the container is really asked to spin up, right? It's cached some of these things, and it can actually go and it's now creating the database, and it's instantiating it with scripts. And if we look at the container ready identified and our test kicked in, so we now got twice successfully pinged the database because our client got instantiated twice. And the second time, it actually came back and returned profile 1, which is exactly what we expected, because if we look at our initialization script, we have inserted into profile the name profile 1, with the ID 1. So hopefully this has shown you how powerful these kind of tests can be, because we've used it to spin up a simple MySQL database where you can spin up so many things, and you can really control how these things should behave. You can spin it up for each test if you need true isolation in your test. If you really need to make sure that there's no environmental things going on, you could use before each instead of before all, and after each, right, to actually spin it up in between each test. You could spin up multiple databases. You can use things like local stack to spin up AWS things. Really anything that can run inside a Docker container and that has some kind of API to interact with, you can use using test containers. It allows you to write tests that are easily replicated across systems between developers. It really is a really great and powerful framework, and I hope you get some use out of. So thank you for watching, and I'll see you in the next one.